Imagine this. Last year, you needed a warehouse-sized data center and millions in compute just to run GPT-3. Today, a model the size of a USB stick just ran circles around it on a single laptop. No, this isn't science fiction. This is real. Meet Phi-3, TinyLlama, and OpenHermes. Models so small, you could run them on your phone, yet powerful enough to rival giants. These aren't just toy models. They're the new disruptors, crushing benchmarks, running faster, and costing almost nothing to deploy. We're entering a new AI arms race. But this time, smaller wins. And if you're still focused on billion-dollar behemoths like GPT-4, you might be missing the real revolution. So how the heck did a model with just 1 billion parameters beat something with 175 billion? Let's break it down. 2. What it is. Concepts simplified. First, let's unpack what these models really are. Phi-3, developed by Microsoft, is a tiny transformer-based language model trained for maximum efficiency. With just 1.3 billion parameters, it delivers performance once thought impossible for models of its size. Then there's TinyLlama, a grassroots effort to replicate Llama's power, but in a much smaller footprint. At only 1.1 billion parameters, it was trained on 3 trillion tokens. Yes, trillion. That's data scale usually reserved for GPT-class models. And OpenHermes? It's part of a family of instruction-tuned models designed to follow complex human commands while staying lightweight. Now, you might be wondering, what's the big deal? Well, imagine a sports car that runs on a lawnmower engine, but still beats Ferraris on the track. That's the power-to-size ratio we're talking about here. It's not just that they're small, it's that they're optimized, open source, and focused. Instead of brute force, they use surgical precision. They leverage smarter pre-training, better tokenization, data curation, and efficient fine-tuning methods to squeeze out every last drop of capability. In a world chasing scale, these models chase efficiency, and they might just be the future. 3. Architecture breakdown. Let's peek under the hood. Phi-3 is a pure decoder-only transformer. That means it focuses purely on generating text, without any extra bells and whistles. But here's the kicker. It uses a 4K context window, enough for meaningful conversations, summarization, and even simple coding tasks. TinyLlama takes cues from Llama architecture, rotary embeddings, pre-layer norm, and grouped query attention, all tricks designed to make the model faster and more memory efficient. OpenHermes adds instruction tuning on top of an efficient base model like Mistral or TinyLlama, giving it improved followability and reasoning. And these models are tiny. You can fit them on a Raspberry Pi with quantization, run them in your browser with WebGPU, even power them on your phone with Metal or Vulkan. That's like fitting the brain of a mini GPT into your pocket. Every component is optimized. From tokenization, often using BPE or sentence piece, to weight sparsity, precision, bfloat 16 or int4, and memory throughput. This isn't just small scale, it's small scale done right. And the results? Shocking. 4. Let's talk training. Phase 1, pre-training. Phi-3 was trained on a carefully curated mix of web data, books, code, and mathematical reasoning datasets. Microsoft focused on cleanliness, relevance, and diversity, rather than just sheer size. Think of it like a gourmet meal instead of a buffet. TinyLlama used a mixture of Common Crawl, academic papers, GitHub code, and filtered Reddit. Despite being small, it trained on 3 trillion tokens. That's more than GPT-2 ever saw, and rivals GPT-3's datasets. It was trained for hundreds of thousands of steps using deep speed and flash attention to minimize memory costs. OpenHermes followed a similar pre-training path, often using the Mistral base, before heading into instruction fine-tuning. Phase 2, continued pre-training. Some variants of these models were trained further on domain-specific data. Phi-3 Mini Instruct was trained with additional math and reasoning sets, making it a whiz at solving puzzles. Phase 3. Instruction tuning. Instruction tuning teaches the model to follow human prompts. Think of it like finishing school for AI. OpenHermes especially excels here, using datasets like OpenOrca, FLAN, and ChatML. Phase 4. Safety plus alignment tuning. TinyLlama and OpenHermes undergo post hoc alignment using human preference datasets or reinforcement learning. The goal? Make sure they don't go off the rails. And just when you think it's done, many of these models are also quantized for deployment. Tools like GGUF, GPT-3, and AWQ shrink them down for 4-bit precision without losing performance. That's like compressing a movie to fit on a floppy disk and still keeping HD quality. 5. Reinforcement learning or tuning. Let's talk about the magic sauce, tuning. TinyLlama and OpenHermes make heavy use of QLoRa, a fine-tuning method that adapts large models using very little GPU power. It's like customizing a Ferrari with just a screwdriver. QLoRa allows developers to inject specific skills, tone, or domain knowledge into the model, all on a laptop with 16 gigabytes of RAM. Then there's RLHF, reinforcement learning with human feedback, which is used in models like Phi-3 Instruct. It fine-tunes outputs based on what humans actually prefer. It's a bit like training your dog to respond better using treats, rather than just yelling commands. The result? Models that are more helpful, less weird, and more aligned with what users want. Some developers also add multi-objective RL tuning model to balance safety, helpfulness, creativity, and length. All this on tiny hardware. 6. Benchmark performance. Now let's get to the juicy part. Phi-3 outperforms GPT 3.5 on reasoning tasks like GSM 8K and math. That's a 1.3 billion parameter model outperforming a 175 billion one. It also beats Llama 2 7B on coding and instruction following. TinyLlama hits 50 plus on MMLU with just 1.1 billion parameters. That's Ivy League level reasoning packed into a Raspberry Pi. OpenHermes, it dominates Alpaca, Vicuna, and even Llama 2 13B in instruction benchmarks. The message is loud and clear: 10 times smaller, same results, sometimes better. And the real kicker? They cost pennies to run. You can host them for free on a Colab notebook or even locally without a GPU. 7. Real-world demo use case. Imagine this. You're building a chatbot for an online store. You load up OpenHermes on your local machine. No API keys needed. Customer asks, "Do you have any shoes in size 9 that match this dress?" The model parses the queue, looks at your catalog JSON, and responds with 3 perfectly matched pairs. Time? Under 2 seconds. Or maybe you're using Phi-3 to help kids learn math. Feed it a word problem, and it solves it step by step, just like a tutor. And the cost? 0. One developer even ran TinyLlama on an Android phone to summarize PDFs. It finished the job in 5 seconds, something that would have taken a human 5 minutes. This isn't a toy. It's the future of practical AI. 8. Final 3 takeaways, plus call to action. Takeaway number 1. Smaller models aren't weak. They're optimized. Smart design beats brute force. Takeaway number 2. You don't need big hardware or big money anymore. The tools are in your hands. Takeaway number 3. This shift towards small-scale AI will change everything, from startups to schools, from edge devices to global infrastructure. This isn't just a new chapter. This is the next wave. The models are here. They're open, they're tiny, and they're crushing it. Are you ready to build with them? Smash that sub. Drop a comment with the smallest model you've run. And let's debate. Is this the end of the giant model era? The revolution won't be centralized. It'll be quantized. See you in the next one.